All right, we've got maybe 2 more chapters. If I can get through them, digestive and urinary. I want to at least get into urinary because that's an important chapter. I'm not going to get to reproduction, so it never happens. I can't get that far. This is the digestive system. So there's 2 parts to it. I'm not gonna write a lot on the board, so I'm just gonna keep it minimized. In the recording, you just gotta make the part in the upper right corner a little bit larger. So there's 2 parts to the digestive system. One part is called the GI tract. That stands for Gastrointestinal Tract. It's a tube. It just starts with a mouth and ends with an anus. It's just one tube going all the way through. And then you have accessory organs. It's not like so important that you're able to see this. It's not like a huge deal. So if you can't see it, it's okay. So you have the GI tract and you have the accessory organs. The GI tract starts with the mouth, which we call the pharynx, which I may or may not have spelled right. And then from there, you swallow the food and it goes down your esophagus. Make sure I'm food goes down your esophagus and into your stomach. Great accessory organs for now. Food goes into your stomach, then into your small intestine. Then large intestine, and it's going to go out. But that's a continual tube. It's just shaped different. Like the stomach's shaped different from the large intestine. They've got different things about them, but it's still kind of like the same thing, right? So we call this the gastrointestinal tract. The esophagus, I view it as just like a hallway. Because you want to get the food down to your stomach, but you got to get it past the thorax. So the real estate of the thorax is taken up by the heart and the lungs. So it's just a hallway to get the food down to the stomach. The main job of the stomach is to liquefy food. Going to turn it into something called chyme. We'll get to that. So the stomach is going to liquefy food. You know what? Let me make sure I don't even have it. I don't. Okay, good. The stomach liquefies food, turns it into liquid. The small intestine, this is where everything's going to be absorbed, all the nutrients. That's why we want to liquefy it first, because we're going to want to absorb all the good stuff out of it. And then once it's out of the small intestine and it goes into the large intestine, this is where you want to get the water back. So you want to reclaim the water or reabsorb water. Then the rectum's going to hold it, and then it's out. That's all right. And that's it. So let's look at it up here. Let's look at it off the PowerPoint slide. Here's your mouth, your pharynx, down the esophagus, and then you see it's kind of dropped behind the liver here. Down the esophagus, behind the liver here, into the stomach. Then I'm still following it. Right about here is the small intestine. So all this in the middle here is the small intestine. So going through the small intestine here, winding through, and then right about here where my pointer is, that's the boundary between the small intestine and the large intestine. So this is the beginning of the large intestine. The large intestine comes up like this, and it transverses across, and it goes down the other side. Does kind of like this little P-trap type of thing, like under your sink, and then that's it. Rectum stores it, and then it's out. So that's one continuous tube. There are organs that we call accessory organs that help with digestion, but they're not part of this GI tract. Up in the mouth we have teeth and tongue. So those are considered accessory organs because your teeth chew up your food and your tongue like pushes the food back so you can swallow it and manipulates the food. So we consider them accessory organs. They're not part of the GI tract, but they help with digestion still. And then you have salivary gland. So you've got up in your mouth, you've got your teeth, your tongue, and your salivary glands. And then then you also have 3 accessory organs down in your abdomen. Those are the ones I'm going to pay like a little bit more attention to once we get to them. Your liver, your gallbladder. So we didn't really get to look at any like cats or anything like that, but the gallbladder, when you lift up the liver, you'll see it right about where my pointer is. Here they're showing it to you here. And it is kind of like it's often like a greenish color. So liver, gallbladder, and then underneath your stomach is the pancreas. So you've got 3 accessory organs up in your mouth. You have 3 accessory organs down in your abdomen. Liver, pancreas, and gallbladder. And we're going to talk about each one of those. Probably not today, but on Monday. Okay, here's your gastrointestinal tract. It's got 4 layers. So the trachea and bronchus, they had 4 layers. They had the mucosa, the submucosa, the I can't think of it right now, the hyaline cartilage, and the adventitia, serosa. It's a little bit similar here. This is obviously not the trachea. This is the GI tract, but they've got 4 layers. Mucosa, submucosa. Here we're calling this muscularis because it's muscle. Muscularis, and then the outer layer is called serosa. Another name for that is adventitia. I think when I was talking about the trachea, I was calling it adventitia. So the difference, the mucosa and the submucosa, we have those same 2 layers. The mucosa, let's look at the mucosa. The lining, same answer that it always is, epithelial tissue. Here, these cells, well, they're different depending on where they are, but they're not going to be flat. They're not going to be squamous tissue. They're going to be either cuboidal or columnar. But anyway, you have epithelial tissue. So that's the first layer, and see it's right here. Epithelium, and then something called lamina propria, which is kind of an elasticy type of tissue. And if you notice in that tissue, you see some of these green things. Mucosa associated lymphatic tissue, or you could just call it malt. So that's kind of from the lymphatic system. That's part of the lymphatic system, right? It's got a lot of phagocytes in it. So if something gets past your epithelial tissue, hopefully some of the phagocytes can like reach out and eat it. And then you have a small layer of muscle here, called the Muscularis Mucosa. And what that'll do is sometimes the lumen is flat. Like if you look at your esophagus, this is kind of like the esophagus. The lumen's flat. But when you get down to your stomach, this actually forms like pits. Kind of like these things here. So they form pits. And then when you go to your intestine, there's actually like little fingers sticking out. And that's what this muscle layer does. It helps to make the different features of this epithelium of the mucosa. So anyway, epithelium, lamina propria, muscularis mucosa. That's all three of those are going to make up the mucosa, the first layer. Then when you look at the submucosa, that gray stuff is just some kind of connective tissue. We've got a couple things in it. You see those glands, Mucosa glands. So Mucosa glands are going to secrete mucus. Right? These are all epithelial cells, but they're always wet. All your tubes are moist somehow. You can't have them all dry out. Right? So even, the lining of your mouth is wet. The lining of your esophagus is wet, the lining of your stomach is wet. It's all wet, right? So it's all layers of mucus. Some places it's thick and some places it's not like that significant. But so here's mucosa glands producing mucus. Like in your stomach, these mucosa glands are making a lot. So if this were your stomach, there'd be a lot of mucus. There'd be like a thick lining of mucus here, made by these mucosal glands. And then you've got nerves. All this yellow is supposed to represent nerves. So there's nerves wired in here. There's nerves wired into these glands. So your body, your brain can make this mucus secrete. And your brain will do it. When you're sometimes when you're hungry, no, not this. Sometimes, like, let's say you're walking through the mall and you smell that cookie store, which I forgot its name.
American cookies.
What is it?
American cookies.
American cookie? That's what it is?
I think so. Yeah, it's been a while, but yeah.
Pretend like it's been a while. Like
It has.
you probably were there last night. You were there last weekend, you didn't know what to do with yourself, so you went to eat food court.
I love the physical cookies from them. I got it.
Man, and they're piping out that smell on purpose. And like, when I walk by it, it's like, yeah, my stomach starts growling. I don't know if it's the same for you guys. Like you didn't even know you were hungry, but like you smelled it, and all of a sudden your stomach's growling. And it's like you notice you're hungry, right? And that's this. That's what's going on here. Like your brain, like you have receptors in your nose that picked up the smell and sent that signal to your brain, and then your brain sent a signal through these nerves down to this muscle. It started making this muscle contract, even though there's no food in it. And then you're like, oh yeah, I'm hungry. And at the same time, what it's doing is it's like secreting, it's like stimulating these mucus glands to secrete mucus. So like you're priming your stomach up to get some food. Just because you smelled, you saw, or even like you saw it, you're at the airport, you see cinnamon. Like, why is that the time? You're about to get on your plane, you're like, you know what? I really could do with some cinnamon. Big 550 calorie bun. Why here? That's the time. But they have cinnamon in the mall.
Cinnamon? No.
That's right.
I guess we should specify what we're talking about when we say mall, because it could be Slidell Mall.
Right, it could be.
The one in, what is that?
Lakeside?
No, Lakeside on the cooking place.
Oakwood. Oakwood got, American Cafe Design.
But they don't have cinnamon.
Yeah, I haven't been there in a while.
I'm feeling like Cinnabon is like a thing at the airport.
I've seen, matter of fact, I think I seen Cinnabon in Texas in one of the malls. That's where I saw the Cinnabon.
Oh.
I never recall seeing one here.
I thought it would do quite well here. Yeah, maybe not. I'm thinking of Cinnabon. That's what's going on. That third layer, the muscularis, is constricting.
It says we're in Hattiesburg, Mississippi.
That's it?
That's all I saw. But I think I saw.
I thought we had one at the airport here. I guess we
It
don't.
may be. I don't know.
Well, it's gonna have to look into that.
I know they have a cafe one at the airport.
But I get turned off by that main Cafe du Monde. Like, it makes me feel like it's just a tourist place. Like, drink your coffee, get the hell out. Like, what do you want? What do you want? Drink it, slam it down, get the hell out of here. Leave a tip, get out, I need the next person to get in. And it turns me off to all the other Cafe du Mondes. I just feel like I'm more of a morning call person, I guess. Check out that third layer, there's muscle here. So you got two things that the nerves are hooked up to. They're hooked up to this muscle and they're hooked up to these glands. This third layer is called the muscularis. So your whole GI tract, your esophagus, stomach, all that stuff has layers of muscle, at least two. And so like this layer, this first layer, they're calling it circular, and it kind of circles around this thing. And this layer longitudinal, so it runs like up and down. So if this were like your esophagus, you got a layer of muscle circling around the esophagus. You got a layer of muscle going up and down. And they're gonna alternate in their contractions. So we call that peristalsis. I think I've got a slide with that. But that's what's moving stuff. Like if you swallow something and it gets kind of stuck in your esophagus, if you were just patient, which I never am, you'll feel it move slowly down. The muscles will start to, this muscularis layer, these muscles will start to contract and push it down. Just that it kind of hurts. Because you're eating like you shouldn't eat. That's why something's stuck in your throat. I swallow stuff like candy. I'll swallow candy just because I want to rush the experience of putting another piece of candy in my mouth so that I can feel that like little high again. I wasn't even done chewing it. Like I didn't finish enjoying the experience, the time with like that brownie or something. I shove another bite in my mouth because I want like that next experience. And it's never the same, right? It's never that first high that it's just like, this is what drug addicts must go through, right? They're chasing that first high that they get
but you never can get that first high back again. It's like that with food, like that first bite of like a brownie or whatever it is you're eating, you're like, oh, this is so fucking awesome. But then later it doesn't give you that same satisfaction, right? And so for me, it's like heroin or something. I just try to eat more thinking that I'm gonna like chase that first bite. When I don't understand, that first bite never comes to me. See, you don't get that feeling back. What was my point? I don't know. Serosa. It's just whatever. It's connective tissue. That's what people say when they don't want to like explain. Like here in the submucosa, I told you it's connective tissue. Obviously, it's not that important, or else I would have tried to figure out what it was, right? And then here at this serosa, this outer layer, I'm telling you again, connective tissue. That's because I don't, there's nothing important to say about it, right? It could be elastic. You know, I imagine that there's elastic fibers in here, but I don't know for sure. It's not like a big thing to know. So you'll hear people say that. They just talk about connective tissue kind of generically. That's fine. So anyway, those will be 4 layers. That's more of an anatomy thing. I'm going to come right back to this, but here's the supply to the nerve supply. And here, like these nerves, if you see these nerves, they're going to the muscle. And then if you follow this down, it's saying myenteric plexus. So they're going to the muscle. And then these nerves are also going to the submucosa. So they're going to 2 places. They're going to these glands, and they're going to this muscle. So that's it. When they go to the muscle, we call it myenteric. MY meaning muscle, right? And then the other one's submucosal. So they're both, a plexus is like a network of nervous tissue, neurons. So this is like a sub. So if you go under like central nervous system, there's like subheadings of it. And one of the subheadings of central nervous system is autonomic nervous system. This is kind of like a subheading of autonomic nervous system, your enteric nervous system. Enteric, like E-N-T-E-R, that's going to tell you something about your digestive system. Entero, like gastroenteritis, that E-N-T-E-R part is going to tell you something about GI tract. So when you see that in a word, that's going to kind of tip you off. So the myenteric plexus is saying that, you know, it's giving innervation to the muscle. I'm going to go right back to it. Just let this person in. So, yeah, that's all I'm writing there. I'm saying that the nerves are going to that muscle and they're constricting the muscle. When you feel hungry, that's what's up. It's the myenteric plexus. Your brain's stimulating that. And then the submucosal is when your brain's making the mucus glands go. Both of these, parasympathetic. We talked about sympathetic because we talked about fight or flight, like we're talking about epinephrine and stuff like that. That's sympathetic, like making your blood pressure go up, making your heart beat faster. All of this is digestion. So this is going to all be parasympathetic, rest and digest. You always just ask yourself the question, do I need this to run away from a snake? No. Okay, then it's always going to be parasympathetic. Do I need to break down my food? And no, not at that moment. But again, we're with cranial nerve 10, the vagus nerve, because that's the only nerve that's going to go past your shoulders. So anything below your shoulders, the answer is going to be cranial nerve 10, or vagus nerve, whatever you want to call it. So, and since all the stuff we deal with is pretty much below the shoulders, then whatever chapter it is, you just keep saying vagus nerve. Most of the time, it's going to be right. If the nerves up in your mouth, then you have to start thinking about it, right? That's above your shoulders. You got to start thinking, well, it's not going to be 10. It's going to be something else. But then my advice is go with 9. Because in this class, if it's not 10, it's 9. But anyway, spend too much time on that. So, yeah, making the mucus go or making the muscle go. That's it. And you do both. When food's going through your body, those muscles are contracting. You feel it in your stomach when your stomach's empty, but you don't really feel it in your intestine. Well, I guess sometimes you do. But that's what they're doing. They're alternating the contractions of their muscle. So you can call that motility or peristalsis. This is looking at like a side view. Okay, so when we talked about the heart, there's a sac around the heart called the pericardium. So there's like a membrane associated with the heart. There's also a membrane associated with the lungs that I never told you guys about because I kind of blew through that chapter. It's called the pleural membrane. So if you see the word like P-L-E-U-R, it has something to do with the lungs. So just like the heart had the pericardium with like a sac around the heart and there was like fluid surrounding the heart, your lungs have something called the pericardium, the pleural membrane, and it's got the same thing. It's got fluid around it. There's like a visceral and parietal layer. Obviously, I'm not going to test you on this because I didn't tell you about it, but I'm just telling you that like there's membranes around your organs. With the heart, we call it pericardium. With the lungs, we call it pleural. Like you can see people with pleuritis. Like whenever they're breathing in, it hurts like a bitch. The other thing that you're going to see people with, it hurts like a bitch, is peritonitis. So peritoneum. And the word is spelled right here. Sort of. I think I've got it right here. Wait, I've got it right there. There we go. I'll just keep it there for now. Peritoneum is a membrane around your abdominal organs. You'll know when people have like an inflamed peritoneum. Just take your pinky and touch their abdomen, and they'll start screaming. Now that I told you, you're going to be tempted to do it. I'm just going to tell you, go ahead and do it. Go ahead and do it. Go ahead and do it. You got to find out. But there's different peritoneum. So I'm gonna come back to this slide here, or maybe I'll just let you write this down and then I'll go backwards, right? So yeah, the greater omentum. So belly fat. There's all these commercials telling you what belly fat is. It's the greater omentum. That's what it is. It's got a bunch of adipose tissue in it, and it's like when you cut open your abdomen. It's not like all the intestines fall out. They don't. All of your intestines are all connected to each other. It wasn't like on that scene on The Walking Dead where Negan sliced that guy open and all of his intestines started falling out. That wouldn't have happened because his intestines are joined to each other by something called mesentery. So they're all attached to each other. It doesn't fall out like that. And anyway, there's something called a greater omentum, which is kind of draped over it. So you gotta, like, when you cut through the skin in your abdomen, you gotta like move that away, and then you're gonna see like this thing of fat, and then you gotta move that away, then you see the intestine. Then you have like, so if you look right underneath so you see your diaphragm, that's like a muscle. Above your diaphragm is the lungs, below your diaphragm is the liver. And, you know what, let me just do it. All right, so here's your diaphragm, And then you see this white thing right here. That's holding the liver to the diaphragm. Liver's actually got more lobes than this. It looks like two here. It's got many, but the main part in the middle is holding the liver up to the diaphragm. That's the falciform ligament. That's one of the 5 types of peritoneum. Then, what you're not really seeing here, but the stomach, this is the stomach. The stomach's being attached to the liver by something called the lesser omentum. Let me see if I can find it. Here we go. There we go, that's better. So, the greater omentum, the falciform ligament is holding the liver to the diaphragm. The lesser omentum is holding the stomach to the liver. So it's not all this stuff's not going to fall out. Even if you remove all the skin here, it's not all going to fall out. By the way, here's the greater omentum. That's more of what it looks like. Like when you make an incision here and open this up, you're not going to see all the small intestine. You can see some of the large intestine here. This is the transverse colon, but it's kind of draping over all of this. So the greater omentum, falciform ligament, lesser omentum, and then if I start to pull some of this small intestine out, you'll see like webbing in between it. It looks like this, like there's webbing in between it all. So that's the mesentery. And then lastly, if I take this large intestine, if I try to pull it out, there's going to be a membrane holding it to the posterior wall called the mesocolon. Well, I don't have a picture of it, so I'm just going to go back to this one. So that's kind of what they do. It's more of an anatomy type of thing, so I don't really tend to ask a lot of anatomy questions, but I might mess up. But together, they're all types of peritoneum. So people do get peritonitis, inflamed peritoneum. I mean, and all this itis stuff is usually because of infection. Pericarditis, pleuritis, peritonitis, endocarditis, whatever. But it happens. All right, so that's peritoneum. It's just a membrane there. I'm not going to ask you anything about the teeth, but there's your teeth. Might have both teeth. No. I don't know. Well, okay. So maybe I'll show you around a little bit. There's the uvula. Right, the uvula is going to block. When you swallow, you've got nerves that are going to make this go up and block the nasal passages so that your food or liquid doesn't go into your nose. You've got glands. Why the name? Salivary glands and salivary ducts. Here's one of them. You got one right under your tongue, the submandibular duct, because you have a submandibular gland kind of like on the floor of your mouth, under your tongue. You've got some other ones. You've got another one on the side here. They're not labeled, so I'm not going to really keep about them. But you've got another one on the side here, and then you've got another one here. So you've got like sublingual and parotid. That's okay. Oh, here we go. I didn't even mean to go to the next slide, but there's your parotid ducts. Your parotid salivary glands. And there's the duct. So that's kind of on the side of your mouth. And then there's your submandibular duct and gland, and then there's your sublingual gland. These things are called frenulums, like that thing underneath your tongue. You got another one there on your lips. That's just FYI, I'm not gonna ask you about it, but we call those frenulum. All right. I don't know why I devoted 2 slides to this, I really don't want to talk a lot about it. It's more of an anatomy thing. Okay, swallowing. Deglutition is swallowing. So you see there's 2 stages to it. So there's 2 stages to it. So you chew your food, you're gonna chew your food up, and when you chew your food up, we call it a bolus. See like right here, B-O-L-U-S. Bolus is chewed up food. A bolus is actually just a mass of something. Like, sometimes like with IVs and stuff, you'll hear like a term bolus or an embolus, like a clot. So a bolus is kind of like a mass of something. Here, bolus, we're talking about food. So your chewed up food that you swallow, we call that a bolus. That's what's going down your esophagus. But anyway, before you do that, you gotta take your tongue and push it to the back of your oral cavity. And then when that happens, you've got receptors back there. So now you're in the pharyngeal stage, pharynx, right? So you've got receptors in the back of your oral pharynx. They are hooked up with your brainstem. See, again here, just like we talked about with the heart and the lungs, you know, I kept talking about the medulla oblongata, like which is in your brainstem. Again here, medulla oblongata. So you've got cranial nerves that are going to the medulla oblongata, and then you've got other cranial nerves coming back down to your stomach and your esophagus and stuff. So I didn't write them. I think it's like the 9th. If I didn't put it here, I'm not going to really test you on it. This is the 9th, I think, glossopharyngeal nerve. That cranial nerve is hooked up to your medulla oblongata. And then you've got, of course, here, I don't have to put anything because you already know what it is. Because if it's going down, I put esophageal stage, which means that it's at least going to your esophagus. So that's probably going to be, and look, I put stomach here, so definitely you know what cranial nerve that is. It's below your shoulders. So this word peristalsis, that means when your muscles alternate in their contractions, the circular and the longitudinal. So I jumped around, so let me go back up a little bit here. So you have receptors at the back of your mouth in your oropharynx. They stimulate the medulla oblongata. The medulla oblongata sends messages back to 2 places. Your uvula. Your uvula is going to block your nasal passage. So the food doesn't go up your nose. Your epiglottis, remember that's part of your larynx. Your epiglottis is going to close over the trachea and keep food from going down your windpipe, your trachea. Those are both activated. That's both your brain making that happen. And then once the food gets past all that and gets into your esophagus and stomach, now we have the esophageal stage. So we're gonna contract the muscles in your esophagus to get that food down to the stomach. You notice here I've got this word cardiac sphincter, so I'm going to go to it in another slide. So, you know, here's the bolus, the chewed up food. This is your tongue. You notice Notice here's the uvula and here's the epiglottis. So you haven't swallowed the food yet. And then look on this side. The uvula has blocked your nasal passages here, and your epiglottis has closed, blocked off the trachea. So the food cannot go up, the food cannot go down your trachea, it has to go down the esophagus. Okay, the cardiac sphincter. So here's your esophagus. Food moves down your esophagus and drops into the stomach. Here, they labeled it the lower esophageal sphincter, which is another word for it, I guess. It is. But the more common word is called the cardiac sphincter. And just think, when that fails, you get heartburn. So heart is like cardiac. They call it that because like this, let me see if I got another picture. They call it that because this region of the stomach is called the cardia. So like, here's the esophagus, here's the stomach, here's like the cardia, and I don't care if you know the regions, really, but there's a sphincter right here. You can't see it, but it's like a ring of muscle. It's like if you close your fist, well, it looks like the anal sphincter. You've got a bunch of those in your GI tract. So you got one of them right here between the esophagus and the stomach. So the food comes down here. The cardiac sphincter is going to open up, let the food down into your stomach, and then it's going to close back again. Because in your stomach, this is all acid. You don't want this acid going up back into your esophagus. Your stomach has a thick layer of mucus, and your esophagus has a really thin layer of mucus. Like, not enough to handle the acid. The stomach has a thick layer of mucus that protects it from the acid. But otherwise, what's going to happen is that the acid is going to start wearing away at the epithelial tissue, at the lining of your stomach. And that's what an ulcer is. You know, when like a peptic ulcer, it's when the mucus starts to wear too thin, and then the acid starts attacking the wall. Or if you get acid too much in your esophagus, you can get an esophageal ulcer. The acid just keeps attacking your epithelial tissue. So that's usually what's causing reflux or heartburn or whatever you want to call it when the cardiac sphincter is not staying closed. Is that a better picture? You can sort of see it here. This is the cardiac sphincter right here. They're not, like, this is kind of maybe a better one where they're labeling it the esophagus. But pyloric sphincter, that's a pretty good shot. Right, so you've got one on the other side too. You got a pyloric sphincter. So you got sphincters on both sides, keeping this acid here. So this region of the stomach is called the pylorus. So that's why this sphincter here is called pyloric sphincter. It's kind of, you're able to see it a little bit better here. You're not able to see it here, but you've got a cardiac sphincter and a pyloric sphincter. This is all acid. So the job of the stomach, its main job is to turn this food into this bolus that's going to drop into something called chyme. Let's see if we've got anything. No, I don't. Okay. So you want to turn the bolus into chyme. Chyme is like liquefied food. It's got like a slushy, it's like a slushy material. It's like the ices you used to get at Kmart. I guess there's no more Kmarts, right? I think they all closed. When I was a kid, there was no like Walmart, like that was the place, that was the Walmart. Kmart was the Walmart.
I used to love Walmart.
What's that?
I used to love, Kmart, I used to love Kmart. I used to always, I was like, going to Kmart, I'm like, yeah.
Yeah, I mean, I don't know when, like, I'm not from here, so I don't know when you guys got Walmart, but when I was a kid, there was no Walmarts.
Mhm.
No such thing. Kmart was the place. Blue light special. But then, like, when I was a kid, they made fun of you if you got your clothes at Walmart. I mean, at Kmart. That's exactly where my mom got my clothes. I mean, if it was like firsthand, then it came from Kmart. And I wanted her to give me money so I could go to the mall and buy my clothes from like Guess or somewhere. But I never got that. But I did get ices. And that's the same type of consistency of chyme. Chyme is spelled C-H-Y-M-E. And I know it's like C-H-Y, and it's pronounced chyme. It's kind of like when you see like a C-H in like medical terminology, when you see C-H followed with a vowel, like followed with a Y, you're gonna pronounce it as, or an I. Like an I, C-H-I or C-H-Y, usually you pronounce it as like a hard K sound. But whatever. And I don't know if I ever told you this before, but like once you start like learning words and stuff, you might be tempted to correct other people. Don't ever correct them. See this word here? It's called duodenum, and it's also called duodenum. And both ways to say it are fine. So you'll hear people say stuff and don't correct them because you might like end up looking foolish. Better just to keep your mouth closed and just do. You don't want to draw attention to yourself. Just keep your head down and do your thing. Yeah, so chyme, that's what it is. And so, we want to turn this into chyme, and how that happens is that there's a couple of ways. One, this is acid. So it's got like a low pH. So the pH scale runs from like 0 to 14, and the lower number you get, the more acidic. This is like 1.8. So it's like really acidic. So you want that because you want the food to, the bolus is dropping into a bunch of acid. And then you notice here there's 3 layers of smooth muscle. Your whole GI tract, the muscularis, has 2 layers, circular and longitudinal. That's in everywhere. That's in your esophagus, your small intestine, your large intestine. Circular layer, longitudinal layer. Right? But the stomach has a 3rd layer of muscle called the oblique, or you could say diagonal layer. See, so there's like one layer of muscle running like this. There's another layer of muscle circling around, and then you've got one that's kind of running diagonal. So it's got a 3rd layer of smooth muscle. So it's beating this food around. Your stomach moves this, it's like sloshing back and forth. And so that's going to break up the food. And then, of course, you don't want that acid, just like you don't want the acid coming back into the esophagus, you don't want to dump that acid into your small intestine. This is your small intestine. This doesn't have that mucus layer either, so you want to you don't want to just dump it through here. You want to just open this pyloric sphincter up very, just a little bit, and let like half of a teaspoon of chyme through at a time. Otherwise, if you keep dumping chyme into here, this acid, you're gonna burn a hole in you're gonna get a duodenal ulcer, right? You're gonna burn a hole in this thing. So you've got antacid. We'll talk about that later. There's an antacid that is going to be secreted into here, like baking soda. It's going to be secreted like right around here. You've got baking soda coming in, Bicarbonate. You have bicarbonate coming in and being an antacid, so the acid's coming from here, bicarbonate's coming from here, and it'll kind of neutralize itself, right? But it's not enough antacid to take care of a bunch, right? So you can only send through about 2 to 3 milliliters. So a teaspoon is about 5 milliliters. So it's about like half a teaspoon. Say half a teaspoon. Just to give you kind of an idea. So there's your pyloric sphincter. And the other thing is, this small intestine, its job, if you look up on the whiteboard, absorption. This is where you're going to absorb. This is where glucose is going to enter your blood. This is where fats are going to enter, vitamins, minerals. So you don't want to dump everything in your stomach, into your small intestine. Because your small intestine is trying to absorb stuff. Don't try to rush it by dumping stuff in there, right? So you just let a little bit through at a time, and then the small intestine will eventually work with that food, and then it'll tell the stomach, okay, well, it doesn't tell the stomach, it tells the brain. Hey, brain, tell the stomach to give me a little bit more. The stomach gives it a little bit more, then it works on it, absorbs all the goodness out of it, sends another message up to the brain. They're actually fighting each other. They have like a little fight going on. The stomach's sending messages up to the brain like, okay, I'm gonna let it all go. I'm just gonna open this thing up and I'm gonna call it gastric empty, right? I'm gonna empty it all out. That's why like when you drink coffee, that's what's going on. It's there's a hormone called gastrin that's coming here, and then the stomach's like, you know what? I don't even care what the brain tells me. I'm just gonna open it up and start letting stuff in. And the intestine is sending a signal up to the brain saying, hey, tell the stomach to knock it off. Like, this is, like, I've got food. I'm good. Let me deal with what I have. The stomach's like, well, this dude keeps eating brownie. I gotta get rid of this stuff. Getting big here. So they're fighting back and forth. All right. So let's look at the walls. So you notice like the epithelial layer here, the mucosa of the stomach, it's not flat. It's got like these folds and stuff. But more important, when you look at the wall of this, like when you get really close to the wall, they make like pits. Like this. Like here's that wall. So you see here's like the epithelial cells. They're going down and they're making gastric pits. This is where stuff is being made. So this is the lining of the stomach, the epithelial tissue. These look like cubes. I mean, not cubes. They look like columnar cells, right? So they're simple columnar epithelium. And there's different cells in here. There's 4 different types of cells, which are on this slide. There's 4 different types of cells, which are going to make different things. So look, here's our layers. Mucosa. And there's a submucosa. We can see some glands. There's some malt. No, I'm sorry, this is submucosa. What am I doing? This is submucosa right here. Screw this up. Right here. This right here is Muscularis Mucosa. There's submucosa. There's your muscularis. Notice 3 layers here. Not 2. And then I guess this one's serosa, this gray layer down here. Anyway, what was I saying? Oh, let's look at the different cells here in the muscularis. They've got 5 here. We could put these 2 together. Mucus cells. One type of cell is a mucus cell, and it makes mucus. Done. Mucus cell secretes mucus. Finished. Then you have parietal cells. So you see 2 things here. Hydrochloric acid. So the parietal cells secrete acid. And then they're secreting something called intrinsic factor. Intrinsic factor is something that attaches to vitamin B12. And without that happening, you cannot absorb B12. So you can eat vitamin B12, but it's not going to enter your bloodstream unless it attaches to Intrinsic Factor. So usually like older people that have B12 problems, it's not because they're not eating enough, it's because they've got like a jacked up stomach and they're not making enough intrinsic factor. But anyway, one of the cells called parietal cells. So mucous cells make mucus, parietal cells make acid, chief cells make an enzyme. And forget about gastric lipase, but an enzyme called pepsin, not pepsin, but pepsinogen. Pepsinogen is going to become pepsin. See, there's another case where we have OGEN. OGEN is a precursor to an enzyme. So pepsin is the enzyme that breaks up proteins. But we have to make it inactive, because if you make an enzyme that breaks up proteins, that enzyme's going to turn around and break the cell up that made it. So you can't make it active, you have to make it inactive. So you make pepsinogen. Pepsinogen is going to come up here, and once it gets up here into the lumen of the stomach, it's going to meet the acid. The acid is going to activate it. So pepsinogen plus acid equals pepsin. So it's inactive until it gets into the stomach juice. And then G cell, which makes that hormone gastrin. And we'll talk about gastrin later. But so you have mucous cells. Who cares if it's neck versus surface mucous cells? Mucous cells, parietal cells make acid, chief cells make pepsinogen. And yes, lipase. Guess what lipase breaks down? LIP. Lipids. ASE, enzymes have two endings, ASE or IN. If it ends with IN, like pepsin, there's really no way to tell if that's an enzyme or not, because lots of words end with IN. So you're not going to really know. But if it ends with ASE, it's an enzyme. So anything that ends with ASE, automatically it's an enzyme. So if I never saw this word before in my life, I'm going to look at ASE and I'm going to be like, well, I know it's an enzyme. And then I'm going to look at this word, I'm like, oh, gastric, like it has something to do with the stomach. I know that because every time you see gastro, gas, something, it has to do with the stomach. So then I'm going to guess. I'm like, well, it's an enzyme, stomach, and I got to figure out what LIP means. All right, there's a reason why, if you haven't taken midterm yet, when you take it, spend a lot of time and like, don't just memorize it for the test. Because that's your cheat code. You're gonna keep that for years. That stays with you forever.
Do we need to know those cells?
Yes. And even like now, like the word parietal, it's like a word you have to learn, right? And it kind of sucks. But in the future, you're going to get to a point where you see the word parietal so many times. Somebody gives you a new word with the word parietal in it, you're good. Like you don't start trying to write it down and think about what it is. You can just relax and concentrate on what it does. Just like pepsinogen, when you see a word like that in the future, you're going to be good with it. You're going to be like, oh, well, OGEN, it's a precursor. Like it'll start clicking. It's just now you're spending so much time writing down words. You have to remember what epithelium is and like, okay, what's lamina propria? But like in the future, you see lamina propria, it's like, it's nothing for you. You're not even going to think about it. I mean, you're just going to instinctively know. It's this layer that's like sitting underneath the epithelial tissue. It's like it's like right underneath the lining of your whatever. You're going to find lamina propria. Right now, you're just trying to keep up with words. So that's what the stomach does.
I should wrap it up. And you know, actually here at this point, the stomach, I'm gonna stop. And then on Monday, I will pick it up again with the small intestine. But the small intestine is gonna absorb things, right? So you have one enzyme already, pepsin, and pepsin breaks down proteins. I'm gonna have a list of enzymes. There's actually about 10 enzymes you're gonna have to know. So pepsin's the first one, number 1 out of 10. Pepsin's the only significant enzyme of the stomach. I was telling you guys to kind of ignore the gastric lipase. I mean, it's there, but it's not like a big deal. You'll see lipase again. But pepsin, most enzymes cannot handle the pH of your stomach. It's too acidic. For example, you make some enzymes in your saliva. By the time those enzymes get down to your stomach, they get, we call it denatured. They get broken up and they don't work anymore. And just to remind you about what enzymes do, if you take a test like the HESI or TEAS or something, enzymes speed up chemical reactions. That's officially what they do, they speed it up. So pepsin speeds up the breakdown of protein. It doesn't break it down. That's the official thing. But unofficially, without the enzyme, it's never gonna happen. It's gonna take years to break down protein, right? And you don't have years. So enzymes make things happen. Enzymes break things down and build things up. That's unofficially what enzymes do. So in this case, we're talking about breaking things down. So all the enzymes that I'm going to talk to you about break things down. All right, so we'll stop there. Does anybody have any questions?